Ye- we will cover the calculation, but not the completely calculation, but I will give you the idea, right? So basically, I will design the complete because if I will cover the complete calculation, so basically it will take lots of time to design the complete mold, right? For the for the complete with the complete calculation for mold design, at least we need around 5 to 6 hours, right? So that's why I will design the complete mold. Don't worry. But calculation you have to learn yourself because you have all the videos, right? Right? Now see, this is the inner part and this is the outer part basically, right? So here I'm just hiding this center component, right? Control Shift I, Control Shift I for ice cream. I for India. है ना? So Control Shift I, just click. You will get this immediate hide option. So basically, you have to just click the body, right? So yeah, it will be hide. Now, for example, where is the hided component? So just press the Control Shift B for ball. Okay, Control Shift B again. So it is known as invert hide and show. Okay. Now you want both component at one screen. So basically, Control Shift U for umbrella, Control Shift U. Okay. So both the component or all the component will be in one screen. Okay. Now see, I'm just hiding these. Now I'm deleting this one. Okay. I don't require this. So I'm just deleting this. So this is the component I have now. Now basically, first of all, we have to analyze the component. See what is the requirement of the component. Is there any internal undercut or the external undercut? We have to check that, right? So first of all, see here, analysis. So analysis, in the analysis, you have to click on draft analysis first of all and check the draft. See, so where is the draw direction first of all? See here, this is the draw direction. So I have to take the draw direction like this. See, now this will be the draw direction. Now here you can see that this green region is nothing but it is the cavity region. This red region is nothing but it is the core region, right or wrong? Okay. Okay, but here you can see that blue and the yellow part and the blue part, you can say that this is the 90 phase. See here. Okay. See, this is the 90 phase means there is no draft here. See, there is no draft. This is the 90 phase. So with the reference of this phase, these are the 90, right? So that's why you can see here. See, this is the phase, this is the phase, so this is the 90. So basically, there should be draft here. If there is a draft, this is so basically, for example, component should be like this. Component should be like this for the molding process. Why? Because it will be the cavity region and it will be the core region, right? Okay, so this is basically this is nothing but this is the draft. See here, right? This is the negative, this is the negative, this is the positive. So component should be like this. For example, if we are dealing with the plastic component, so every component has some draft, right? Around zero point 0.5 degree or the 1 degree or the 2 degree draft should be there, right? Okay. Okay, but here there is no draft, right? So basically, we can extract this component from the core head cavity, even if it has a 90 phase, because its length is very low. You can say that its length is very not much higher. You can say that, right? See, what is the length right now? Just check the length from this point to this point. Just check what is the length. 8 mm only. Atom. Okay. So 8.2 mm is, or you can say that if the component height is less than 15 mm or the 20 mm, so basically you can extract the component uh, within this length, right? In 90 phase. For example, if it has a 90 phase, so you can extract the component easily, right? So there is no issue. But even if you can provide the draft, so basically you should, right? Like for example, like I'm just trying to provide the draft, है ना? Minimum draft you can provide. So I'm just providing the draft. Take the draft here. This is the draft, right? I'm selecting this. This is the stationary phase. Okay. and just select this all face. Now see, take tangent face like this. Deselect this. Wait, just take the single face. Take this face first of all, and take the 0.5 degree. If we can provide, so I'm just trying to provide the draft. Let me check. Can we? Okay, 1 minute. Again, take the draft. This is the stationary face. Take this. Now take the single face. Take 1 degree to this face. See? Okay, like this. Like this. Right? And here also, I should provide from here. This. Yeah. Yes. No, both the faces. I will keep one face in completely in core side and one completely face or complete slide on the cavity region. Okay, 1 minute. Let me complete this. I'm taking the 1 degree draft. Let me check. See, now this is the draft here, and just click OK. Let me check again. I have not selected these faces. Wait, see, okay, and just click OK. See, okay, and now I'm just deleting this face because I have to prepare a slider here. Can we delete this? No, we are now. Right now we can. Let me check if we can delete this. So I'm just deleting this face. Na? There is no requirement for this face right now. Let me check again. See, okay. Now again, okay. And here, if I can provide the radius. So basically, what we are doing right now, we are trying to make the component feasible for molding process. Yes. Okay. Basically, we are as a designer, you can say that no, we are not a CAD design engineer. Basically, what we are the tool design engineer. It means we have to deal with the component feasibility as well as for the tooling or the mold tool also, right? Okay. So now see, just take the tangent face and I am just providing the some radius. So 1 mm radius can we provide? Yes, we can provide the 1 mm radius, minimum radius, right? Like this. See, this is the 1 mm radius. And now this bottom face. So I'm just coloring this face for the highlight. See, and see here. This colored face is nothing but this is the core region now, right now. Core region and this completely complete with the cavity. Now see again take the draft and see the component. 1 minute. Draft analysis. Now see where is the draw direction? Draw direction should be here, right? So 90 again 90 like this. Okay, and minimize the draft. See here. Now here. See. Okay. Now here this blue face, this will come under the undercut basically. Okay. So basically for this I have to prepare a undercut. Right or wrong? Okay. You can say that we have to prepare a slider or the side core, right? And or here you can say that. See, this portion is also come inside the undercut, right? See, yes, right? See here, yes. Okay. So now, first of all, we will extract the core and cavity, which is very important. Okay. Now see, I will prepare. This is the cavity. This upper part is cavity region, and this lower part is the core region. Okay. Now, so basically, we have checked the feasibility now. And first of all, one more thing we have to check, which is the machine. Now, what is the machine capacity? For example, customer has a 30-ton machine. How much? 30-ton capacity machine. Okay, so for the 30-ton machine, we should have knowledge about the machine data, right? Like what is the injection, what is the short capacity, tie bar distance, right? Tie bar distance and tie bar distance and ejection stroke and materials, material. So clamp, this is nothing but 30 ton. It means it is the clamping force. It is the maximum clamping force. Okay, or we should have knowledge about the injection pressure, right? Which is the minimum and the maximum, right? So we should have knowledge about that also, right? Okay, this is very important. Now, this is the basically we have to prepare the two cavity mold. So basically here you can see that this is the slider part. This is the slider part. It means where will be the gate location? This will be the gate location. Okay. So basically we are preparing or we are making two cavity mold basically. Okay. If we are making two cavity mold, so it means two cavity mold and cold runner mold. Cold runner mold. Write down this all these things. Okay. Okay. So two cavity mold and the cold runner mold. So we cold runner means basically this will be the gate position and this will be the runner. Okay. And again this will be the gate position. This will be the second component like this. Like this. Okay. So this is the cold runner basically. Understood? Okay. And this is the edge gating. Now. Okay. I'm just age. A- Age means because we are using this gating on the edge of the component, that's why it is known as edge gating. Now basically gate selection is depend upon the customer requirement. Okay, what is the requirement of the customer, or depending upon the component appearance, lots of things there, right? So that's why depending upon that we have to select the gate depending upon the customer requirement, as I told you. Okay, now see, this is the component. Okay, so I'm just taking the plane, not plane. I'm taking the datum CSYS, and this will be the center. Okay, this will be the center. Now control T for Tamil Nadu. Okay, just click on component, and here see this is the control T for control T for move the component. I'm just trying to move the component because we have to prepare the layout of the two cavity, right? See, so control T. Okay, select the component. Okay, I'm just moving this component. From which point I am just moving? From the specify point. This is the specific point C. And from this point, or where I want to put the component at this point. See, and just click OK. See, during the move, if you are moving the component, so during the moving, you just tick on associative. Okay, just of this move parent, of this update and dependent feature, and of this create trace line also, right? Just you have to tick only associative. Okay. Okay. Now, what is the manufacturing possibility? What is the manufacturing possibility? You have not seen the lectures in proper way, right? See. Yeah. Okay. See, for example, like this is the component. Sorry, no, not the component. This is the plate, steel plate. Okay. If this is the steel plate, so here you can see that. See, this is the hole. For example, this is the hole. Okay. Now I'm trying to prepare two hole. So this is the, yeah. Now see here. 1 minute. Now this is the hole. See, this is the first hole. Okay. Now again, I'm making the second hole. See. This is the second hole, just for example. So basically, what is the manufacturing feasibility is that from one feature to another feature. So this is the ending of one feature or this is the ending of another feature, right or wrong? So it means between two these features, there should be a minimum distance. There should be a minimum distance, right? So this is known as manufacturing feasibility. For example, if this distance is only 2 mm, it means it's a weak joint. You can say that plate will be weak, right? If this will be the 10 mm, it means it's a this portion is the strong portion, strong one. Okay, so you can say that from one feature to another feature, there should be a distance. Okay, there should be a distance. So basically, for the feasibility, I can take 15 to 20 mm. Okay, which will be in generally. Just I'm talking about that this distance can be, it can be changed depending upon the dimension. It can be changed depending upon the dimension. For example, if the dimension is 100 mm, so basically I have to take minimum 40 to 50 mm between two faces, right? So depending upon that dimension we have to change this. This is the basic idea of manufacturing feasibility, right? Now see now here you can see that this is the core face, right? Okay, I'm just moving this component again. How much? Because from one component to another component, there should be a 20 mm distance, right? So I'm just moving this component. How much? 20 mm. But 20 mm in minus direction. One, two, like this. 20 mm in minus direction. See? Okay. So this is the identical component basically. So I can mirror this. I can mirror this component. Yes. Okay. See, so basically from one component to another component, what is the distance right now? 40 mm. Okay, so here, yeah, 40 mm. But this is the one feature, this is the another feature, but I'm taking the 40 mm distance. What is the reason? Because in mid, you can say that there will be a runner, right or wrong? Runner. But if I'm taking one component here, if I'm taking one component here, so basically it will be a four cavity mold. We can prepare, right or wrong? So you can say that our runner will be in a star shape like this, right? So I can take one gate here, one gate here, one gate here, and another gate here, right or wrong? Right? So basically there should be a distance, okay? And if I'm talking about the dimension of the runner, so this should be 10 mm. Okay, you can say that less than 10 mm. Okay, but minimum you can say that it will be around 10 mm or approximately about 10 mm. Okay, 10 mm. Yeah, 10 mm. So 10 mm diameter is enough for flowing the any type of plastic material, right? But depending upon the calculation, we can take 6 mm, 8 mm, 10 mm, 12 mm, but depending upon the material. Like for example, if we have a PP material, the maximum you should take 10 mm. But in the calculation, if, for example, if you get 5.5, so you can take the 6 mm also because you don't want to waste the plastic material, right? Okay. Now, if for example, yeah, 12 mm you can take, 14 mm you can take, but for the more viscous material like PC or the PP material, PVC material, because this material are the viscous material than the this PP material, right? So that's why for the PVC, which is has a higher viscous material, we have to use 12 mm, 14 mm, depending upon the calculation also, right? Okay. Now see here. Okay. So, for example, like this is the multi-cavity layout I have prepared. Okay. So you want to, for example, you want to make the uh, four cavity mold. Okay. So can we take the position for the four cavity? We can prepare the layout for the four cavity also. है ना? There is no issue about that, right or wrong? Okay, so let's take the current four cavity, but before that, we have to understand that we can prepare the four cavity or not. Okay, we have to understood that thing. So now this is the basically how much undercut this component have right now. Tell me how much undercut this component has now right now. But undercut. So basically, do we require slider from here or from here? From this side? We need slider from this side also? No, 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 no. No, no. Basically, this side, this undercut is nothing but this is the same undercut here. See, this is the same undercut. You can see, you can see, you can see. This is nothing but this is a single one. See, right? And here you can see that this is whole, which is this is whole, and this will prepare for this. We have to prepare the pin, which will be connected with the core plate. Okay, so this is the single undercut. Basically, you can say that, right? Yeah. Okay. Now see. So if this is the single undercut, means now see, this is the one slider only here. Okay, this is the another slider here will be. Here will be the another slider and here will be this another slider. So basically it will be the four slider or the multi slider mode. So single slider required for the single component. Okay, understand? Oh, you can say that. Single, right? Now see, take the pattern. Circular pattern, just I'm taking the circular pattern and take the four and each will be on 90 and just click OK. See, now again try to understand. If I'm making the four cavity layout, so again see what is the distance between these two faces. It should be 15 to 20 mm minimum, right? Now check the this distance. This is nothing but this is the feasibility. And if we are trying to make the mold for any type of components or the multi cavity, so basically we have to check this feasibility, which is very important. Now I'm just taking the random uh, curve. I'm just taking the random curve. Like this is the second one. Now from this point to this point, it is about 9.3. So you can say that from this point to this point, it is about 8 mm. Yeah, approximately 8 mm, right? So I have to change this distance. Again, I'm just yeah, move this component again. I have moved 20 mm. I'm moving 10 mm more. Okay, and now see, understood? Understood? Okay. So this is nothing but we are making the layout. Okay. Now again try to understand. This is the core face. So I'm just taking the sketch on this face. Okay. Okay, 1 minute again. I'm just taking the sketch on this face. Okay. And just attach this. Attach this. So this is nothing but this is the sketch for the runner, right? Okay. I'm just making the one sketch. 1 minute. I'm just making the single sketch. Okay. Just trim this one, and just click OK. Okay. And once we prepare this complete runner, so basically I will pattern this. Okay. Now let me check MacTube. Okay. For example, just I have calculated the runner. Okay. Depending upon the calculation, I got the 8 mm diameter. Okay. Now, what is the runner diameter? Tell me. Uh, yeah. What is the formula for the runner diameter? W to the power 0.5 multiplied by L to the power 0.25 divided by 3.7, right? Okay. Now if I'm taking the edge gate here, so for the edge gate, H, which is the height of the gate, and into T is nothing but wall thickness of the component, or N is the material constant. Okay. For PP, we have to take 0.7. For PVC, we have to take 0.9. So basically, it is depending upon the viscosity, right or wrong? And T is the wall thickness, as I told you, right? Now, width of the gate. This is all about the gate, right? Now width of the gate, which is the h into 2. Okay, so if you get the h about 1.5, so what will be the w, which is the width of the gate? 1.5 multiplied by 2, which will be a 3 mm. Okay, just just suppose. Okay, and this is the basic calculation. Okay, now I'm just making the runner. Take the runner, single curve. Just take the 8 mm and just click OK. See, 8 mm is more. Just I'm taking 6 mm. Okay, if the material is PP, for example, so what is the density for the PP material? Tell me. Density is 0.90 gram per centimeter cube, right? Okay, just put the density 0 point or the 0.90 gram per centimeter cube. Just put this density to the component and just try to find out the mass. Now, what is the mass of this component? Just convert into solid. See, just click on this. So you will get the mass. See, what is the mass? 4.2 gram, right? 4.2, because this value is in kg, so it is 4.2 gram, maximum 5 gram weight of the component. You can say that, right? So 5 plus 5 plus 5 plus density. Just type here density. Okay, type here density. You will get the edit solid density. Okay, so just you see here edit solid density. This is the icon here. So just yes, put the density here in gram per centimeter cube and select the component and get the mass. Okay. Now, just I'm just offsetting the face. See how much? 1 mm. Just I'm taking 1 mm. Okay, and 1 mm from here and 1 mm from here, and just click OK. Right? See. Okay, then take the radius 3 mm here, 3 mm here, and just click OK like this. Okay, now again edge gate, as I told you, edge gate. Now this is the face. Okay, now wall. What is the wall thickness of the component? See, I'm just taking the wall thickness. Is the wall thickness? Let me check. Okay, how much? 1.8 mm, right? 1.8 mm is the wall thickness. Now, if the 1.8 mm is the wall thickness, so just calculate few things. 1.8 multiply by 0.7, which is for PP. Now, tell me what is the value? You will get the height. You will get 1.26. So, should we take 1.26 value? Now, we should take 1.5, right or wrong? 1.5. Okay. And now if the 1.5 is the height, so how we can find out the width? 1.5 multiplied by 2. So you will get 3 mm. Okay. Okay. So just I'm just hiding this and just this is the entire assembly, and this, let me check control Z. Again, I'm taking a rectangle from this point. Take the dimension. I'm taking this dimension, and this is the 1.5, right? Take the 1.5, and this is the 2.5, and just mirror it, single curve, 1, 2, and 3, and send this is the center line, and just click OK. So it will be the 3, right? And finish it. Nothing but it is the length basically here. Length. So yes. So here for the edge gate 1 to 1.5 I can take. So as we offset before, right? So we have offset the 1 mm. So basically I'm just taking the curve inside this body, you can say that, right? Only for the extrusion purpose. Okay. Now 1.5 is the height. 1.5 is the height. So here will be the height. Now you can take the draft. How much minimum draft? 5 degree you can take. See, now here you can see that. So replace this face with this and just click OK. Now see, OK, and take the radius. Take the radius here. Just 1 mm radius can we take? No, zero point 0.5 take a radius. 1 mm radius we can take and just click OK. See, right? Okay, so here I have provided the radius. That's why I have take the 1.5 mm because of the radius. Some material has been gone from here, right? Right? No, no, depending upon the manufacturing. For example, if you have a tool room and you have a minimum cutter of a 2 diameter, so basically 1 degree, you can say that one radius, 1 mm radius, you can make easily, right? Yeah, so depending upon that if the manufacturer feasible or not for making this, depending upon that. But we should provide the radius, right? Because we have to apply the ball nose cutter there, right? For making this. Hmm. Just take the 1 minute. This is the mirror geometry. Just click here and this face and this face and just click OK. See, right? Mirror and just unite this with this with this and just click OK. And if we can provide the radius here, so you should provide radius also, right? How much can we do? And click OK. See, okay. Sometime you have seen like this also. 1 minute. I'm just taking the not. Sometime you have seen in some mold, right? You have seen like this also. Have you seen? See, see, like this, right? You have seen before. No? Uh, this is more easy then. But the same dimension with the same dimension. Okay. See, like this. Nothing but for the smooth flow, you can say that. Only for the smooth flowing. Hmm. Right. So this is the now just I'm taking the pattern. Like the pattern. Where is the center? Just take the two. It will be the 180. No, one not 180. I have to take 90, right? And just click OK. See, okay. And just unite this. Unite this. And just click OK. See. So we have prepared the complete layout. And a multi-cavity layout, you can say that. This is the multi-cavity layout. Right? Now we can prepare the core and cavity. Now we are ready for preparing the core and cavity. Now see the core and cavity. Just I am taking the sketch here like this. Take the sketch. See like this, like this. Okay. Now here from this point to this point, what is the distance? Let me check. What is the distance? 22 mm. Okay. And here will be the 22 mm, right? Now I'm just taking the distance, this and this. So as we told you before that from one feature to another feature, there should be a how much distance? minimum, right? 15 to 20 mm, which is the minimum distance. But if I'm taking the 185 days, if I'm taking 185 days, so is it okay for us? Can we take 185? We can, but manufacturing process will be, cost will be higher because of this selection. Why? 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 Tell me. You have any idea? Not the machining idea. For example, if you are going to market and you want to purchase you want to purchase this raw material, right? So you will get the 185 by 185. Yeah, we have to go for the standards. So basically, you can say that your diameter, your dimension should be like this. Like this should be 200 mm. You will get easily. This should be 200 mm. You will get easily. Otherwise, you have to purchase this 200 and 200. Then you have to cut from here. You have to cut from here. Then you have to make the size, right? So it will basically this will produce the more you can say that what complexity, right? Cost you can say that. So it will increase the cost. So basically just take the standard dimension. So take the 200 mm and take the 200 mm. Understood? This is very important. This is the very basic thing, but very important, right? If you are making the mold, so basically our concern is we don't want to increase the mold cost. We want to reduce the mold manufacturing cost. Okay. Okay. Now just I'm extruding this. Now see, we are making the core basically, right? So this is the core. If this is the core, so how we can prepare the core? Then how we can prepare the length? How we can take the length or the height depending upon the cooling channel. Yeah, cooling channel. So now our component thickness is around approximately 2 mm, right? So for the 2 mm, how much diameter of the cooling line I can take? Tell me. 8, 8 to 10 we can take, right? So I can take 10 mm. If I'm taking 10 mm, 10 mm, so from this point to this point, what is the distance of this? 20. Yeah, this will be the 20 again. 20 mm, right? Yeah. So just take the height. So how much height I can take? 40 mm distance and just click OK. See, 40 mm for the insert. Okay. And again, what is the height of the component? Let me check what is the height. Height is nothing, component height is nothing but it is about 11.2, 10 mm you can say that. So basically I can take the 50 mm, right? 50 mm. So this is all the standard size 200 by 200 by 50 mm. So basically this standard size I will get from the market, right? Easily. So that's why manufacturing cost will be reduced there, right? So just I'm taking the colors. This is nothing but this is the core and this is the cavity. है ना? This is the cavity. But now I have to extract the core and cavity, है ना? Which is more important thing. See, okay, this is the core one. 1 minute, let me check. So first of all, I have to prepare the inner portion or the side core portion. You can say that. So I'm just trying to extract the core and cavity. Let me check. Here I'm just using the surfacing command. Just to offset the, just taking the offset surface. Take the zero value and just I'm extracting the inner surface. Okay, let me check. Can we take extracting the inner surface? No, we cannot. So first of all, let me check. 1 minute. Okay, so this is the one curve. This is the second one. Okay, so I have this. Okay, see, so this is the inner. So try to understand. See what I'm doing right now. I have this curve. I have this curve. Let me check. I have this curve also. Let me check. This curve and this curve and this one, right? I'm just extruding, nothing but extruding. Okay. Now see, uh, and I'm extruding this till selected. Until selected, see. Okay, like this. And just click OK. See, there is a issue. There is a issue here. See, right? There is a issue. So yeah, this portion is not covered here. So for this, I have to use some. Let me check. I can modify the component, right? Because right now I have to prepare the four cavity mode. So don't worry, I will modify the component. Don't worry. Okay. So let me check extrude and take the not this extrude this. Just take this. Let me check. Take this and take this and take this. Okay. In order to make the core and cavity for this component, I'm just trying to okay and just none and just click OK. Offset, offset, one and just click OK. See, okay, let me subtract this. Let me check 1 minute. Just mirror this to face and just click OK. Or let me subtract this from the component. I think now is it okay? See, okay, now it is not undercut. Is it undercut right now? Understood? Or I have just modified the component. Okay, I have just modified the component because for the easy, because otherwise I have to extract I have to make the slider here also, so we cannot make the 4 cavity mode, instead of it uh, we can modify the component, but for that we have to ask to the customer, which is very important, right? So I'm just modifying this component and see, this is the 4. Just click OK and just delete this right now and take pattern. How much? 4, 4, 4 at the 90 and just click OK. Okay. And and move and this one and this one and this one and just click OK. See, it is modified completely. Okay, so basically this is the final component we have. Okay, my voice is clear or not? Tell me. Hello, Kumar san. My voice is clear. Voice clear. Okay. Okay. 1 minute. There was an internet problem in my area right now, basically, but now internet is resumed, basically. Let me check. Now my voice is clear. Tell me, clear? Okay. Internet is resumed, basically. Okay. Now see. Okay. This is the cavity portion. This is the okay. So here, just I'm check. Take the pattern geometry again. Take this and just click OK. See. Okay. Now we can prepare the core and cavity, right? How we can prepare the core and cavity? Now see. First of all, see, subtract from this and subtract all these features. Capital on and just click OK. Okay. Just hide this center one. See. Yeah. Okay. Keep tool is nothing but while you are subtracting something. Like for example, you have subtract, like I'm just hiding, deleting again. See, for example, like we are subtracting like from here, right? And this is the tool basically. This is the selected body, and you want to subtract this tool. This means you want to subtract this. So basically, it means if you are subtracting this, so it will not invisible from here. It will be visible again, or it will be subtracted as well as it will be here. Okay, so that's why keep tool on. Keep tool on. It means it will be subtracted, but it will be here in future. So basically, you want this, right? That's why. So just hide this, hide this. Okay, hide this. Okay, hide this. Right. Now this center portion. See, this is the cavity, and this is nothing but this is the core basically. Okay. Now this, what is this? What is this? This is nothing but this is the slider part. This is the slider part. So I'm just giving the different color for this. See, this is slider part, right? Hiding this. Okay. Just unite this all small block with the big one. Let me check. Finish. Just finish this and unite this with this and just click OK. See, right? And where is the component again? This is the component and the runner, and subtract from the core, keep tool on and just click OK. See, start this, right? So this is nothing but this is the core, and this is nothing but this is the cavity. So we have prepared the core and cavity with the complete layout of the four cavity. Okay, understood? Now again, Control Z. We have to prepare the interlock. Interlock. Now, what is the interlock? Interlock is nothing but it is used for the central alignment of the core and cavity. Because we are dealing with the, what is the main thing? Core and cavity, right? Alignment of the core insert and the cavity insert is very important to each other, right or wrong? Okay. Take the 25 mm, take the 20. This is the random dimension. Okay. It should be feasible for the manufacturing purpose or nothing, right? So I'm just taking the 0 from here and take the 15 mm. Okay. And just click OK. Or take, yes. What is the minimum drop for this? Minimum? No, no, not 1 degree. Minimum 10 degree. minimum 10 degree, huh? Minimum 10 degree draft we should be there. And edge blend, take the 5 and just click OK. And here, just mirror this here and just click OK. Mirror this like this and just click OK. Okay. And unite this, right? This is the core and subtract from the cavity. Keep to on because we have to subtract this, right? From here. See, we have to subtract this Capilon. Hmm. Yes. Select the target body. Select the target body. Yeah. Basically, for example, if you want to subtract this body, it means it will be the tool body. Okay. And from which body you want to subtract? So this will be the target body. Okay. Cavity is the target body. Core is the tool body. Yes. Okay. Now see. Okay. So you understood about this? This is the core and cavity basically I have created. Okay. Now, see core and cavity I have created. Now try to understand. See, now I will make the housing. I will make the housing. Okay. Now just click on this. Okay. And I will prepare the housing. So take the center. This is the center. I'm just taking the center one. Now tell me what is the size available into the market again. Yes. Basically, I have to use some feature here like this. What is this? Guide pillar and the guide bush I have to use, right? One more thing is return pin I have to use here. Okay. Okay. So basically, here you can see this is the dimension 200 by 200, right? Okay, this is the 200 by 200. So from this point to this point, what is the distance basically? This is with the 50 mm. This is the 50 mm, right or wrong? So in 50 mm, no, this is not the standard. Basically, for this guide pillar, I have to use the calculation for the selection of the diameter of the diameter. Guide pillar diameter, right? So calculate if we need calculation. So by the calculation, for example, like if your mold size is about 300 by 300, so generally you will calculate the diameter of this guide pillar. It is around 22 or the 24 mm or the 25 mm, right? It will be like this. Okay, and this is the feature. This is the feature. So from one feature to another feature, again, distance should be 15 to 20 mm. So that's why 50 mm from this side to this edge is feasible, right or wrong? All the component will be here. All other component will be in this space, right or wrong? My voice is clear or not? My voice is clear? Okay. Let me resume the recording also. Okay. So basically here I need to design the guide pillar and the guide bush. Okay. Guide pillar and the guide bush. So I'm taking the 300. So that's why 300 mm is the feasible and it will easily available into the market also, right? Okay, just click the OK. Okay. Now see, I have to take the height. Now how we can select the height? What was the height of the 1 minute? What was the height of this? It is about 40 mm, right? So I have to take how much? 60 mm I can take? Can be. Yeah. How much I can take? This is the 40 mm. So how much I can take? 60 mm? 65 mm I should take, right? Why 65 mm? Because here you can say that 1 minute. Let me check 1 minute. Okay. So Control J and just click OK like this. Okay. So why I have take the 60 mm here? Because I have to use the core. I have to use the cooling channel, right? And now how cooling channel will be work? Because here like this, cooling channel will be from here. It will be inside this. It will be like this, right? It will be like this. Now see how much. See again. See again. Okay, cooling channel will be like this. See from here, it will be inside this, right? So here will be the o-ring or the gasket. You can say that, which is used for the preventing the leakage. Okay, and now it will be circulate like this inside this. Okay, not like this. It will be circulate like this, like right. And again from inside, it will be out here. This will be the inlet, and this will be the outlet. I don't know. Understood? Now Control J and just click OK. And this is the core, right? This is the core. Again, but here this is the core. So I'm just taking the 1 mm from here, and this is the 66 I'm taking. Okay. So here, what is the reason? Because I'm taking the 1 mm more this. See here. Where what but why I'm taking this? Because this surface should be meet with another surface of the cavity, right? So both the core and cavity should be meet to each other in a proper way. So there is a no matter of this surface here. So there is a that's why there is a distance between both surface, right? So I'm yeah, this is the cavity one. I'm just taking the extrude again. Okay. And how much? 50 mm basically, right? So I can take the 75 mm this. I can take the 76 and 1 mm offset from the side course or the face side, right? See, Control J and take the color. This is nothing but this is the cavity housing. This is the core housing. Core housing, right? Now, just time. Let me check. Extrude. Get the region. 0. Okay. And just subtract from this and just click OK. See, right? And again, I'm just taking this face. Control J. See, again, I'm just taking this face. See, this face. Right click on this. Take the upper face of this. Just subtracting and take this body and just I'm subtracting from here and just click OK. Why? Because this is nothing but this is the housing for this inserts. This is nothing but this is the housing, right? See, let me show. See, Control H. See, this is the housing basically, right? See, hide this and just click OK. See, okay. Now take the radius from here. I'm taking radius. Let me check. Control J and just click OK. Like this. I'm just taking the radius here. Why I'm taking radius? 1, 2, 3, and 4. How much? 10 mm radius I can take and just click OK. Okay. And resize this blend 1, 2, 3, and 4. Taking 8 mm and just click OK. Hiding this and take again resize blend. Take 8 mm and just click OK. See, so what is the reason of this? Yes. Yes. What is the reason? Yeah. What is the reason? Yes. What is the reason for offsetting that? See, let me check. See, there is a clearance between both face. See, okay. What is the reason? Because we want to we want to insert this cavity inside this, right? So basically, there should there should be clearance on corner. That's why. Okay. So understood. See. Now, again, this is the cavity housing, this is the core housing. Now, one more plate I have to create, which is nothing but which is the top plate. Okay. And what is the thickness of the top plate? Which is available. Yeah, thickness. Yeah, we can take. Basically, we can take. But we will get the exact dimension. So we will not take the exact dimension. But if the 30 mm is available, so I will take the 30 mm, right? 30 mm. Okay. And one more thing is that just hide this, just hide this. So this is nothing but this is the complete fixed half, you can say that, right? Fixed half. This is the moving half. Moving half, right or wrong? Okay. Now, again, this is the fixed, this is the moving. Now, again, I have to create one more thing is that spacer. Yeah, just take the dimension for this spacer. So, I'm taking 50 mm. Again, this is the 50 mm and just click OK. See, and just extrude this. Okay, now how we can select the height of the spacer? Tell me, what is the component height? Hmm. Okay, component height is 15 mm, or approximate 15 mm plus. We need a 10 mm clearance, right? 10 mm clearance plus. Okay, so I'm taking 15 mm for the ejector plate and plus 20 mm for the ejector back plate plus 5 mm for the rest button. 5 mm for the rest button. Okay, and just click OK. See, this spacer. And one more plate I need, nothing but back plate. Okay, bottom plate. Okay, take the 30 mm, just extrude this. Let me check. Extrude this. This is the 30 mm and just click. Okay, okay. So just offset this. 1 minute. 1, 2, 3, and this will be the 4. Take the 25 mm. Let me check. Take the 25, 25. And just click OK. So this is the clamping area. Control J. 1, 2. This is the bottom and the top plate. And this is the spacer one. Okay. Now I have to design one more, though two more plate, right? In which one is the ejector plate and ejector back plate, right? So Okay. Between these two faces, what will be the clearance? From this point to this point. Okay. No, 5 mm. Only 5 mm is enough for between those two plate. Right. Yeah. 5 mm. Okay. And just click OK. Just to extrude this. Take the 5 mm from here. Take the 25 mm here and just click OK. And just I'm extruding this. The reason just 0, it will be the 15 mm and just click OK. See, like this, right? Okay. This is the ejector plate and ejector back plate. Okay. Okay. Control J for the color. Coloring, right? See. So we have prepared the complete mold base, you can say that, right? Okay. Now I have to prepare one more thing is that guide pillar and the guide bush. Okay. Guide pillar and the guide bush. Now how we can prepare the guide pillar and the guide bush? Because we need a calculation for that. You understood about these things? Understood? Okay. Now, okay. So for example, now you want to extract, you want to calculate the guide pillar diameter. So how you can decide the diameter, guide pillar diameter? Tell me. No? See, basically, guide pillar diameter is depending upon the complete weight of the mold base. Okay. And the how much length of the pillar you need. For example, if length of the pillar you need around 60 mm, 60 mm. Okay. So if you need this 60 mm, it means you with the 60 length, you need some diameter also for the shaft. Okay. So basically, this diameter or diameter calculation is depending upon this both thing, right? Okay. So you have to watch that video. Okay, for the proper calculation. So right now I'm just taking the random diameter because I know that what is the needed diameter for the 300 by 300 mold. Huh? That's why. Okay, just I am higher taking this, take this and just click OK. I'm taking the diameter. Okay, 25, 25 diameter and just click OK. Double click on this sketch again and take the dimension. Okay, dimension should be in a proper way. Okay, like uh, like this. Okay, so I'm taking 25 mm from here, 25 mm from here. Okay, and this, okay, let me check again, 25 mm from here and just click OK. See. Okay, and for example, if you have calculated the diameter, but with the diameter you remember one thing, you should take the standard guide pillar and the guide bush. Okay, you can use the when while you are designing any mold for the customer, so basically you can use the DME standard or the Hasco standard or any type of company standard, like you can use the Maruti standard for the guide pillar and the guide bush. Okay, so any type of standard you can use, by which they can purchase the standard parts from the market. Okay, this is very important. Okay, I will show you 1 minute. Let me check. Let me make this first of all. See, so I'm taking the length, for example, like I'm taking length of 50 mm. Why I'm taking the length 50 mm? Because length of the pillar from this face should be higher than the component height plus clearance. Because at the end, why? Because the guide pillar is used for the alignment for both mold half, right or wrong. So alignment should be good. So basically, your pillar should be go inside. First of all, your pillar should be go inside the bush, right or wrong? For the proper alignment of the core and cavity, right? So that's why its length should be more than component height plus clearance. Okay. So I'm just taking these. I'm taking chamfer. I'm taking the asymmetric chamfer and just I'm taking 1.5 distance and just click OK. See, this is the radius again. Take the radius like here and click OK. Just hide this one and take the standard color. Okay. See, and the 0. I'm taking 6 color or the sometime 8 color depending upon the dimension or the standard, right? So I'm taking 2.5 offset per side and unite with this and just click OK. See, and yes, of course. Yeah, of course. I'm just showing you. Don't worry. So example, I'm just tomorrow I just working. I was just working on a mold. See here. So, see. So this HPDC mold I have created for the customer. See, see here, right? This is the HPDC basically. So see the standards. See, this is nothing but this is the guide pillar and the guide bush, the standard diameter for from the Maruti tools. See, guide pillar and the bushes. See, so here this is the material and the hardness. So here you can see this is the K, L or D value. So now you can easily read from here. See, right? So this is all the standard item. So basically we will get easily from the market. So that's why there is no issue about that. Okay, understood? And similarly like bush, you can see the bush also. See, this is very important, right? See, so just like this. Okay, I'm just providing the air vent if there's a possibility. If you are taking the standard, so basically there is no requirement for designing the vents here, right, on the guide pillar. Alright. So uh, yeah, air vent or the you can say that basically on the guide pillar we have to use the lubrication, right, oiling. So so that's why for the smooth alignment between the both the matting part lubrication or this type of groove is very important, right? Okay. So this is the pillar, and I'm just taking the like this. But calculation is very important. Okay. Once you calculate, so basically that diameter you can select from this standard. Okay. Now hide from this. This is the extrude and subtract from this one and just click OK. Finish this. Okay. This is the feature one, mirror feature. Apply to. Okay. See. So similarly, take this standard dimension. Okay. So this is the bush. Okay. I'm taking right now. This is the 25. I'm taking here 32. No, not 32. I'm taking 36. And just click OK. Okay. Okay. And like this and like this and just click and finish this. है ना? And cancel it. So basically we have prepared some sketches. Use the split command and split this complete block with this circles and just click OK. See, Control J. So this is the method for creating the bush from the same block, right? See, okay. Now you can prepare the collars. My voice is clear or not? Clear? Okay. See. Again, 8 mm collar, take the none and take the two-sided offset and on different sides. Okay. It is the, let me check 1.5. Okay. And 2.5 per side and just complete. Okay. And unite this. Right? Got the guide flare and the guide bush are the ready. Like this. Okay. So now again, you have to prepare the one more thing, which is the sprue bush. The sprue bush you have to prepare. See, so where will be the location for the sprue bush? On the center of this plate. So now take this sketch. Now guide bush. Yeah, guide bush will be see here. This is the location of the guide bush. Yeah, basically top plate will provide the support to this. So basically that's why this have a collar here, right? Okay. So now again take this circle and view. Let me check. This is the center and take the bush. This is not the standard item. Okay, so we have to use is bush is not the standard item. Okay, depending upon our requirement, we have to create this. Okay, if we just finish this and Control J and just click on, let me check, Control J and just click OK and translate this, just click OK. Okay, and take the extrude minimum 16 mm you can take. I'm taking the 16 mm and just click OK and again take this like this. Okay, like this or take the single sided offset. I can take 5 mm per side and just unite this with this. Just click it. Okay. Subtract this bush from this plate. Let me check. Control Z. 1 minute. Subtract this bush and okay, not just click OK like this and subtract again this bush from the okay. See, okay, like this here. So what is the standard diameter for the locating ring? This is the standard part. 90 mm. No, no, generally 90 mm we should take. This is the standard part. Take the and just click OK. Remove from this and take the chamfer from here. 30 mm, right? So symmetric 30. So 30 mm, I have take 30 mm thickness, so I can take the 18 mm and just click OK. So 12 mm will be the thickness of the locating ring. Okay. By the locating ring, I'm locking the sprue bush also. For that, 30 mm was the diameter of the sprue bush. So I'm taking the 28 mm here, not 28, 26 mm here, 26 mm here, and just to finish this. Okay, extrude this and none, and take the another curve and this will be the 0, this will be the 12 mm, and just click OK. If 12 mm is the thickness of this, so take the chamfer, and this will be the 10 mm, and just click OK. See, right? Take the Control G and color the spring, sorry, locating ring, and take the color for the screw bush also. I'm taking the green one and just click OK, like this. Okay. Now take the Control J and just let me check and remove the transparency. Okay. And here, diameter aperture hole. Now aperture hole, for example, now if the machine nozzle, machine has a aperture hole about 3 mm or 3.5 mm. So how much we should take here? 4.5. If the machine nozzle has a diameter of 5 or the 5.5 mm, so we have to take more than 1 mm. Okay. Like this, and just click OK. Yes, 2 to 5 degree. 2 to 5 degree. Just hide this. See, right? Like this. Just until selected, select this face. Can we select this? No, we cannot select this face. Just take this and unite with this. Take the draft 2 degree. Okay, -2 I have to take like this and just click OK. See, okay. Here I can provide the radius. Take the radius 2 mm. I can take. Let me check. 1 mm I can take. See, right? But where is the bush? This is the bush. Okay, so from the bush, subtract this runner, and just click OK, and just hide this. Now you will get the profile like this. See, okay, okay. Now we have to provide the decut also. We have to provide the decut also. For example, like during the operation, it will tilt like this. It will take 5 degree from here, right? Like this. See, so what happened? Because of that, we have to provide the decut or the locking, you can say that, right? Which is very important. This is all the basic things. So we have to provide the locking to the bush. How we can provide the locking? We just provide the decut. Okay. See, yes. Okay. Just provide also like this and just provide the decut. Just split this, use it by this curve and just click OK. And now this is nothing but this will be the part of this. Just unite this split with this. Just click, right? So this is the decut basically. Hmm. Yeah, we are just locking this. We are just locking this bush with the plate. So that's why there is no possibility for slipping during the operation. Okay. See. Now see here. Yes. Now we unite with the plate. That cutted part will unite with the plate. Yeah. Yes. Okay. So decut has been produced. See here. Like, see. Use the Control T for removing this. Like this. See. So this face. I'm just coloring this face. 1 minute. This face is nothing but it will be the G6 uh, or the slide fit. You can say that fitting purpose only for the fitting purpose. So this is the decut basically, right? See. I hope you understood about this. Just delete this command. See here. So we have created the complete mold base with the screw bush, locating ring, complete four cavity, and a layout. You can say that. And now Okay, one more thing, ejector plate. So we have completed the fixed half portion. See, right? Okay, fixed half portion. Now, where is the ejector? Where will be the ejector? Where will be the location for the ejector pins here? Tell me. At center, but why? For yeah, for basically, for example, if we want to eject the component, so first of all, we have to ask to the customer. Basically, customer suggestion is very important for us. Yeah. Like for example, if we are providing the ejector pin like on the center here, right? So if a customer says that sir, this face is very important for the appearance purpose, then what happen? So basically, we cannot provide the ejector pin here, right? Yeah. So for that, we have to discuss with the customer. So what approach we can use here, right? If customer okay we can provide the ejector location here, so we can provide basically, but so discussion with the customer is very important, first of all, right? Okay, so right now, for example, we are dealing with the multi-cavity, and this is nothing but this is the household product basically. So we can provide the ejector pin here. Okay, is it clear? So just I'm taking the sketch on this. Right now, I'm just providing the ejector pin. Let me check. Mm, अच्छा, और लेकिन what will be the diameter for the ejector pin? Tell me. Which nahi, again which is available on the market. Understood. Which is available into the market, right? Like for example, 10 available. Yeah, of course. 10 8 6 This all the diameter are available, right? And this ejector pin is also, you can say that if we are using the ejector pin, so this is the standard item, right? So 8 I'm just taking, okay, right now. D, just take the dimension, and from this I'm taking 8 and just finish it, okay. And I'm just using only single pin, okay, single pin for the single component, and like this, and take the ejector plate. This is the ejector plate, and just click OK like this. Extrude. Now see, okay, like this, and just click OK. Let me check. Extrude this one also. And this is the 6 and again I'm taking the single sided. I'm taking 2.5 and backside, and just unite this with this and just click OK. And like for example, like if this ejector pin rotate on its axis, so there is a problem there. Tell me. But it is problem for the component. Tell me. No, this. But there is no problem if we do not provide the D cut here. There is no problem for the rotation because it's the straight face. That's why. If this is the curve face or the profile face, so basically we have to provide the D cut there. Yeah, so there is no requirement for the D cut here, right? So yeah, center. Let me check and just click OK. Take left 4. Okay, like this. This is the ejector pins, right? 4 ejector pin for the 4 component. I'm just taking. Just 1, 2, 3, 4. Keep tool on and just click OK. See? Okay. Now again, 1, 2. Okay, let me check. 1, 2, 3, and this will be the 4. And just click OK. Just hide this. And again, subtract. from this insert. One, two, three, and this will be the four. And just click OK. Now this is the insert we have. So we should provide the clearance here because we do not need a precise dimension here, right? Because we have an insert. So I can take the 1 mm per side. 1 mm per side. See, right? So it will be look like this. Control J. See, understood? This is understanding is very important. Okay, so this is the single cavity. We are preparing the single cavity. Oh, sorry. So four cavity slider mold right now. Okay, so we have prepared the complete mold base. Now here, uh, one more thing. Okay, so we need a bolting. Okay, again for the bolting, we have to select the bolt, but with the help of calculation, right? So for that, you have to see the lectures. Okay. Ah, number of volt is depending upon us, but calculation is very important, right? Once you, yes, per load, you can say that. For a complete, for example, for a force is required. Just for an example, you required 100 kilonewton force. Okay, you require 100 kilonewton force. So basically, per bolt, how much bolt? For example, if you are using the 4 bolt here, so on per bolt you can say that 25 kilonewton, right? Right? Okay, so 4 bolt. If you are using the 6 bolt, so basically you can divide by 6. So basically per bolt will be around 18 or the 17, right? Okay, so depending upon that, how much bolt you are using. But generally we can use the 4 bolt because because it is feasible, right? Otherwise we required more machining there, right? That's why. Hmm. Just hiding this. Okay, and just let me check and just click OK. Okay, and extrude this. I hope you are understand about all these things. Understanding? Okay, very good. So here, let me click and just click OK. Now bolting we required. I'm just taking the bolting. So see, just take this and just click OK. Mm, view. Okay. Mm, let me check. Okay, here is the pillar. Sorry, here's the spacer, right? So I should take this bolt in this direction and distance. I'm taking 45 mm distance right now. Okay, let me check on minute. Okay, I'm taking the 45 mm distance. Five mm distance and take the CYCS. Use the mirror command and apply again. Apply and just click OK. You will get some point. Okay, so here, so for the reference, you can take the sketches. Okay, take the counter board and take the M12. This selection is depend again. I'm telling you, this selection is depending upon calculation, right? Okay. So where is the points? Let me check. The points are not selecting. Why? and point one, two, three, and this will be the four, and just click OK. Okay. You can change the dimension if you required. See, this is the bolting. Again, we can bolt this plate, this spacer, and this one also. Right? Use this and just click OK. Like this, two plates. We have this, and take this sketch here. Point. This is the 1 point, second, third, and this with the fourth, and just close and finish. Okay, just escape this, just click OK. Take the hole, one, two, and just click OK. Third, and this will be the fourth, and just click OK. See, okay. Similarly, we have to clamp these two plates also, right? Okay. Now here we have created the ejector plate. Okay. So we require return pin also here, right? So I'm just providing the return pin. Let me check. This is the what this is the plate. So I'm providing the return pin at this location. See, so here, okay, I'm getting a 20 diameter for this and just click OK. Take the dimension from this face. I'm taking 20 mm, 20 mm, and take the dimension from that which you can write and for vertical 25 and just click and finish it. Extrude this just and just click OK. Again, take the collar. How much? 6 mm. As I told you, which is available, right? 2.5. Or unite this. Unite with this and just click OK. Okay. And again, double click on this rod, and this will be the 1 mm minus 1 mm upper side. See, like this. Okay. And we have to provide a rest button also. We have to provide a rest button also, which is connected with the cavity housing. Okay. See, so here Control J. See, just to mirror this. Again, mirror this. This is the plane. And just click OK. One, two, mirror, and this like this. One, two, three, and this will be the fourth, and just click OK. Okay. Now, as we have created the guide pillar and the guide bush for the alignment of the complete mold base, right? So similarly, we have to provide the guide pillar and the guide bush for the ejector grid. Now, guide pillar is connected with the bottom plate. Guide pillar is connected with the bottom plate, right? Now, for example, like let me check. One, two, three, and now guide pillar. So just I'm providing one guide pillar, okay? So you need a four guide pillar, just providing here at this location. So I'm taking here. Mhm. B and just inferred and just click OK. This is the 45 distance I can take and take the dimension. I should take here. Let me check 14 and take one more sketch which is on 15 and now I should take dimension. How much? 22 for the pillar. Okay. Now see, until selected until extend and just click OK. For the chamfer, just click. See, understood? See, this is nothing but this is the pillar, and similarly we have to provide the bushes. Okay, so by splitting this two plate by the circular curve. Okay, so you can provide the bushes also like this. See, this is nothing but this is the pillar. Control J and just subtract this. Let me check. Pillar from here. Let me check it again. So 3 and 4 and just apply. And from here also 1, 2, 3. This will be the 4 and just click OK. Just hide this plate and this plate like this. Understood? Hide this 4 pillar also and connect this pillar with the bottom plate. How we can connect? Tell me. 1. Let me check. Partially. 2, 3, 4. And just give a bit. I have prepared some points, right? Right. And 8 you can use here. Apply. Helmet. 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 See. Understood? My voice is clear or not? Okay. See. Now you want to need provide the cooling also. Now how you can provide the cooling? See, so maximum component you have created, right? Okay. Now, for example, now as the for the manufacturing purpose, you have to provide the reference hole also. So, what is the purpose of the reference hole? First of all, tell me. Huh. Now, for example, in future, for example, you want to prepare the same core and cavity on this plate. Something is happened, for example, something is make accident with the feature of the core and the cavity, you can say that. So basically you have to machine, you have to take the machining also, you have to prepare the machining also. Again you have to prepare, you have to take the machining, right, on the core or the cavity plate. So basically you need a few reference, you need some reference, right? So that's why basically we have to prepare the reference hole. So there is no use of that hole on the surface of the core or the cavity, but for the future reference we have to we for the future reference we should use this hole for the dimensioning. Basically we have to provide the dimensioning or reference with this hole, right? Let me check 1 minute. 1 minute. Just let me create this first of all and hide just on this and just click OK. Just for example, this is the reference hole here, right? I'm taking the S7 face, okay? Let me check. Okay, this is the hole, right? Let me check. Now, for example, this all the dimension, this feature dimension, the all the dimension, you have completed the 10,000 or the 20,000 shots. So all the features like these, like these, like this, all are the deformed, right? But what happened with this? There is no difference. It will be same here, right? It will be same here. So basically, if you provide the drawings, like for example, if you are providing the drawings from this hole, like you are providing the dimension of this from this hole, this center, like this center, or like you are, so basically in future, you know, you yeah, yeah. So basically in future, you know that where is the center, what is the distance of this face, what is the distance, what is the, yeah. So for the future reference, this is very important, right? Okay. Okay. Now, one more thing, reference cut. So what is the purpose of reference cut? Like I'm providing the reference cut. Yes. So for the proper aligning of the molding or the complete mold plates, we have to provide a reference cut. This is only one side, single side, right? This is the reference cut. Now I have to provide the again one more thing, which is the cooling. Now how we can provide the cooling? Now I'm just providing the simple zigzag cooling right now. Okay. Now this is the cavity side I have. Like for example, this is the cavity side I have. Okay. Now Control J, just translating this. Okay. See, just hide this also. Now see, again Control J and provide the translucency to this body also. Now see, so I'm taking the plane. Okay. Now from this point to this point, what is the distance? So I'm taking on mid. Okay. So I'm taking plane on mid. Okay. Right now I'm taking plane on mid. Okay. Let me check. 1 minute. Not not on these. I'm taking plane on these. Let me check. See, I'm taking plane here like this. Okay. From the face of this about 20 mm. Okay. So what is the distance right now? Now see, like this. This is 67. So it is about like this 50 mm. I'm taking. Okay. On the 50 mm. Okay. See. So minus 50 mm and just click OK. See, understood. And one more plane I am taking from this face. So it will be on 10 mm. Can I take 10 mm? No, let me check. No, not 10 mm. I have to take on 15 mm. So from this point to this point, it is about 30 mm, right? See, right? Like this. Now try to understand. Hmm, I'm just providing simple cooling right now. Take the sketch on this and click OK. Okay. I'm taking like this. Okay. Take the dimension and take the dimension in this space. So you will get an idea how to prepare the cooling. Okay. Now see, this is I have taken the stick how much? 65, right? I'm taking the 70 mm dimension for this. See, again not 70, and taking ATM dimension. See, okay, and here location should be here, right? Let me check again. 120 and again, and just click OK. See, again 130 I should take. Yeah. See, now right now I'm just making a line. Right now I'm just making a line. Now see, take the dimension here like this. Now take the partial. Now see, take this. I'm just taking 50 mm. Okay, so this will be the 130 mm. This will be the 25. From one cooling to another cooling, 10 mm diameter I'm taking. So from one cooling to another cooling, how much distance should be there? 25 I can take. Okay, and like this will be the 130. So 130 minus 25, how much? 105. Okay, again, like from this 25. Okay, like this distance again. And I'm just taking the dimension from here and take the dimension from here and trim it from here again. Okay, and just click. Just okay, right? Now again I'm like this, see, and take the mirror. Where is the mirror command? This is the mirror command. One, two, three, four, five, and this will be the six and seven. Take the center line like this. See, I'm just making the simple type of line pulling. Again, this is the again one more mirror I'm taking. Let me hide this and just click OK. See, right? Just connect all this. Now try to understand. See, just I'm connecting all these things. Just hide this also. Taking the 3D curve, take this point and connect with this. Take this point and connect with this and just click OK. And where is the tube one? This is the tube, right? See, 10 mm, right? Apply, 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 just apply, apply, apply. Okay, let me check. Just apply. Let me check 1 minute again. I'm adding all these things. Let me check. Okay, hit this one also. First, this single curve. Apply, apply, and apply, 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 and apply, apply. Right. Okay. See, and just hide offset this face. 8 mm, 8 mm, 8 mm, and 8 mm. Why I'm offsetting this? Let me see. Tell me why. Yeah, we can. Let me check. Okay, see, because when we drill by the radial drilling, so basically this impression will be there, right? That's why I'm. So okay, see, just apply and unite all these things. Just click one and unite all these things and just click OK and just use mirror command and like this plane for the mirror. Yes, again, yes, unite this and this. Just click OK. This is nothing but this is the zigzag cooling, which provide the proper cooling to the component. But remember one thing, when you are providing this type of cooling, there should not be interruption for this cooling. See, any type of there is a interruption into this. See, now if there is no interruption, it means this cooling will work in a proper way, right? Now, depending upon the wall thickness, we will select the diameter of the cooling, which is very important. So depending upon that layout, okay, or what layout we are creating, okay, depending upon that our cooling will be performed. See, yes, this is the cavity side, but in cooling in core side you can say that there is a pins, ejector pins. Because of that there is a complexity, right? But you can provide, because that's why I have provided only the single ejector pin for the single component, so there is no complexity right now. If we provide lots of ejector pins there, so there is there can be a complexity, right? Yeah, that's why. I hope you understood about all these things. We have provided the cooling also. Okay, so once you provide the cooling, once you unite all the cooling channels, you can subtract from the cavity sides or the from the plate also, right? Okay, now one more thing is that you have to practice. है ना? Yes. Yeah, without